Okay, next of all, we need to go over the trig functions again because it seems like some of you had trouble with that on the test. So let's just go back and remember what the trig functions are. If you have a right triangle and you have some angle in that triangle, we'll call this angle theta. And suppose the sides of this triangle are A, B, and C, then we would say the sine of theta, this angle, is equal to the opposite side to theta divided by the hypotenuse. The opposite side to theta is over here, that's A, and the hypotenuse of this right triangle would always be across from the right angle, that is C. All right, if we want to look at the cosine of theta, and let me make sure you understand that you would never see the word cosine just sitting there by itself. You have to talk about an angle because you don't know which side is opposite or which side is adjacent or which side is what unless you're talking about a specific angle in the triangle. This is a function. It has to have what we call an argument. You have to be putting something into the function, and that thing is the angle. So don't ever write just plain cosine. We're talking about the cosine of something, of an angle. All right, so the cosine of this angle theta is the adjacent side, that is the side that's right next to it. So adjacent side over hypotenuse. So in this triangle, you've got theta, the side right next to theta is the adjacent side, which is B, and the hypotenuse is still C. The hypotenuse is always the longest side of the right triangle. The tangent of theta is equal to the opposite side to theta over the adjacent side. So here's theta. The opposite side, as we saw in sine, is A. It's across from theta. The adjacent side to theta is touching theta. It's B. So these are the trig functions. You can only find the trig functions in this triangle if you know which angle you're talking about. All right, so those are the trig functions for the angle theta, but what if we called this angle, say we call it angle B, capital B. And please remember in math that capital B and little b are two totally different things. They are not the same. If you use a little b for a variable and you use a capital B for a variable, they are not the same variable. So please don't use a capital letter when it should be a small letter or vice versa. So if I wanted to find the sine functions for the angle B, the sine function, I would say sine B this time, and that's going to be opposite over hypotenuse. Now the opposite side to B is little b, and the hypotenuse is still C. If I want to find the cosine of angle B, that is going to be adjacent over hypotenuse. So there's your adjacent side. That's going to be A, and your hypotenuse is still C. If you want to find the tangent of angle B, that's going to be opposite over adjacent. The opposite side to big B is little b, and the adjacent side to B is A. So you can see that you can't just talk about the trig function of the triangle. That doesn't work. You have to be talking about a specific angle so you know which side is opposite, which side is adjacent, etc. The hypotenuse, you don't really need to know an angle because it's always the same. But in order to talk about adjacent and opposite, you have to know what angle you're talking about. So please don't let me see you writing things like cosine equals, or tangent equals, or sine equals. There must be an angle right there next to it, okay? So take a look at this example. We want to use trig functions to find the missing parts. Round your answer to 2 decimal places. Okay, so let's say we want to find angle F. Triangle has 180 degrees total inside of it, so 90 plus 32 plus f should equal 180 degrees. So that is 122 plus f equals 180. So f is going to be 58 degrees. But I want to find it using trig functions, but it will equal the same thing. But the reason I want to do that is because you also need to know how to use your inverse trig functions. All right, so let's start out using angle 32 degrees here and find m and n. All right, let's talk about what we have and what we don't have. 32 degrees, we have the adjacent side is 5. That's the side that touches 32 degrees. So we have the adjacent side. Which trig functions involve adjacent? The cosine of an angle is equal to adjacent over hypotenuse. So we will use cosine to figure out what n is, because that's the hypotenuse. We have the adjacent, we have the angle theta, and so we can use cosine. So cosine of 32 degrees is equal to 5, the adjacent side to 32, over the hypotenuse n. All right, now n is in the denominator, and that means we need to multiply both sides of this equation by n so that we can get it out of the denominator. If we do that, we're going to have n times cosine 32 is equal to 5. All I did was multiply both sides by n. Now we can get n by itself by dividing both sides by cosine 32. The cosines will cancel over here, and we'll end up with just n. So to figure this out, you have to use your calculator. There's no way for you to figure out what the cosine of 32 degrees is just thinking about it all day. The only way to do it is to use a calculator. So you're going to take your calculator, and you will do 5 divided by cosine of 32, however your calculator does that. Usually you will have to put in 32 first and then hit cosine. After you do that, you have to hit the equal sign so that your calculator will do the division of 5 divided by cosine 32. So 5 divided by, and then hit 32 cosine, then hit equals. And you should get about 5.90. So that is n right there. Now, we want to find m. We could do that by using the Pythagorean theorem, but since we really need to practice our trig functions, I'm going to use a trig function. So again, we have the adjacent side to 32. M is the opposite side to 32. Which trig function involves opposite and adjacent? That would be tangent. Tangent theta is equal to opposite over adjacent. So let's use tangent. Tangent 32 is equal to m over 5. This time, the 5 is in the denominator, so we just need to multiply both sides by 5. And if we do that, we will have 5 tangent 32 equals m. And now we just need to punch this into our calculator. We would hit 5 times 32 tangent equals, and we would get that m is about 3.12. So we have our m and we have our n. Now we want to find f. Like I said, we already found f by just adding up all the angles in the triangle and making that equal to 180, because all triangles, the interior angles, those 3 angles will always add up to 180 degrees. However, I want to go ahead and use one of the trig functions to find f so that you will see and make sure you know how to use inverse trig functions. So we can use any of the trig functions we want because we know all the sides now. I will just use sine because why not? So the sine of f is going to be opposite, 5 is opposite to f, over hypotenuse, which we found out was 5.90. Now, I have to use inverse sine to find f because I don't know the angle. I can't take the sine of f if I don't know f. So I can't use sine. I have to use inverse sine. That is the function you use when you know the ratio, but you don't know the angle. So I'm going to do inverse sine, that's sine with a little -1 up there, of this ratio, 5 divided by 5.90, and I am going to use my calculator. I am going to punch in 5 divided by 5.9, and then I'm going to hit equals. So that fraction has now been divided, and now I'm going to hit inverse sine. That is going to give you 57.94. And this is why, in general, I would just add up the angles in the triangle to find f, because that's going to give you the exact value. The reason we didn't get the exact value of 58 degrees is because we rounded that 5.9. Remember, it was not an exact value when we got it over here because it was some big long decimal, so we had to round it. So it didn't give us the actual value of f, but it's very, very close. All right, I want you to do this one by yourself, so turn off the video and try to do this one by yourself completely, and then you can turn the video back on and you can see how you did. Okay, let's see how it went. First of all, we could find x by using the Pythagorean theorem, and I will go ahead and do that just because I want to make sure you know how to use the Pythagorean theorem. Remember that the Pythagorean theorem says that if you add the squares of the legs of a right triangle, okay, the legs are the two sides that meet at the right angle, and the hypotenuse is the long side that is across from the right angle. If you add the squares of the legs, that's going to equal the square of the hypotenuse. So Pythagorean theorem says that 4 squared plus x squared is 6 squared. Okay? You can't just put these numbers in any order you want. The legs, the two sides that meet at the right angle, have to be on one side of the equation. The hypotenuse squared has to be on the other side. So 16 plus x squared equals 36. If you subtract 16 on both sides, you're going to have x squared equals 20. If you take the square root on both sides, the square and the square root will cancel and you'll just end up with x, and then you'll have the square root of 20. We know that we can write the square root of 20 as the square root of 4 times the square root of 5. The square root of 4 we know is 2, so that is 2 times the square root of 5. So we know that x is going to be 2 times the square root of 5, and that is the exact value of x. We know two of the sides, 4 and 6, and so we can use those two sides to find the missing angles. We know 2 square root of 5 also, but since we already have the 4 and the 6 and they're whole numbers and they're rational, we'll just use them. All right, so if we're looking at angle A, 4 is the adjacent side to angle A. It touches angle A. 6 is the hypotenuse because it is across from the right angle. So I've got adjacent to A and I've got hypotenuse. Which trig function involves adjacent and hypotenuse? That is going to be cosine. So cosine A is equal to adjacent over hypotenuse, and the adjacent side is 4 and the hypotenuse is 6. So I know that that is just 2/3. And I can now use my calculator to find A. But I can't take the cosine of A if I don't know what A is. I don't know the angle. I have to use the inverse trig function. So cosine A is 2/3. Therefore, the inverse cosine of 2/3 is A. So I don't know the angle. I use the inverse function. Inverse cosine of 2/3 is equal to A. So you're going to punch that into your calculator. You're going to hit 2 divided by 3 equals, and then you're going to hit inverse cosine. And you should get that A is about 48.19 degrees. Okay, now we want to find B. If we're looking at B, 4 is the opposite side to B, and 6 is the hypotenuse. That is sine. So I'm going to say sine of B is equal to opposite, which is 4, over hypotenuse, which is 6. And so now we have sine B equals 2/3. So we're going to use our calculator again to find B. We can't take the sine of B if we don't know what B is. So we have to use inverse sine. Inverse sine of 2/3, the ratio, is equal to the angle. I'm going to punch that into my calculator. I'm going to hit 2 divided by 3, then hit equals, and then hit inverse sine. And B should come out to be about 41.81 degrees. And if you look at the angles you have, 48.19 and 41.81 is about 90 degrees, and that's always going to be the fact. When you add the two angles in the triangle that are not the right angle, you should get 90 because all the angles in the triangle should add up to 180. And since the right angle is 90, 90 plus 90 is 180. Okay, this is number 6. Write 3, 4 in polar form, round numbers to the nearest hundredth. So we are going to first of all graph this point 3, 4. That's 3 to the right and 4 up, and there's the point. And now we're going to draw the line from the origin to the point, and we're going to put R because that's what we call the radius, and we're going to show the angle theta. All right, so we need to find out what R and theta are so that we can write this in polar coordinates. So first of all, we can use the Pythagorean theorem to figure out what R is because we have a right triangle with legs 3 and 4. So 3 squared plus 4 squared should equal R squared. Now, that's 9 plus 16 equals R squared. We add 9 and 16, we get 25 equals R squared. So if R squared is 25 and we take the square root on both sides, that means that R is equal to 5. So we found our R. Now we need to find theta. This is our angle of rotation. We're going to go from 0 degrees, which starts right here. And then we're rotating counterclockwise to our radius right here. So we have to figure out what that angle is. And to do that, we're going to use tangent because we have opposite. The opposite side is 4. The adjacent side to theta is 3. And so we're going to use that tangent to find theta. So the tangent of theta is 4 over 3, opposite over adjacent. We don't have the angle, and when we don't have the angle, we need to use inverse tangent. So inverse tangent of 4/3 is equal to theta. Now we're going to punch that into the calculator. We're going to hit 4 divided by 3 equals, then we'll hit second function, tangent. And if we do that, we're going to get that theta is about 53.13 degrees. And so now we have our R and we have our theta. So our answer is going to be 53.13 degrees. Okay, now we have a system of two equations and two unknowns. We are going to, first of all, graph these two things because they are lines. We can tell that these are linear equations because each of them has x and y, and they're both to the first power or less. So we don't have anything, any variables that are above first power. So those are linear equations. So first of all, in order to graph them, that's the first thing we're going to do is graph. We want to put them in the form y equals mx plus b, because that is how we can see the slope and the y-intercept of a line. So we're going to put these in that form. So for the first equation, I'm going to add 3x to both sides. So I'll have 2y is equal to 3x plus 2. And then I'll divide by 2. And so I'll have y equals 3 halves x plus 1. So now I have it in y equals mx plus b form. And I can see that b, the constant, is 1. So 1 is the y-intercept, and so I'm going to put a dot right there on the y-axis where 1 is. So this is what I'm talking about right here, 1. And I put the point on the graph. And now the slope for this line is 3 over 2. That means I go up 3 and over 2 from the point I just put on there. So up 3 over 2 puts me right there. And now I can draw my line. Looks like that. All right, now let's look at the second line, x plus y equals 6. So we're going to get y by itself, y equals negative x plus 6. So now I can see that my y-intercept is 6. So I can put a dot right there on the y-axis at 6. And my slope is negative 1. So I can go over 1 and down 1. And that will be another point on the line. So I can draw the line right there. So those are my two lines. And I can see that it looks like they cross at 2, 4. I can't be sure until I solve the system of equations that it is exactly 2, 4, because a graph can only be so accurate. So now I'm going to solve the system of equations. I'm going to use elimination because I can see that I have a negative 3x in the first equation, and the second equation has just an x. And since the signs on those two things are opposites, I think I'm just going to multiply the second equation by 3, and that way the x's will add up to 0 and they will go away. So if I do that, my first equation stays the same, negative 3x plus 2y equals 2. My second equation, I'm going to multiply everything by 3, so 3x plus 3y equals 18. And now I can add the two equations together. The x's cancel, and I end up with 5y equals 20. And if I divide by 5 on both sides, I get that y is equal to 4. So that is my y coordinate, and that looks like it's matching what we got in the graph. And now if I take that 4 and plug it back into either equation, I can find out what x is. I'm going to plug it into the second equation, x plus y equals 6. So x plus 4 equals 6, which means that x must be 2. So I'm getting 4 and 2 for my x and my y. If I want to show that this point works in both equations, I just need to look at both equations and see if it all works out. So if I put in the 2 for x and the 4 for y, I've got negative 3 times 2 plus 2 times 4, which is negative 6 plus 8, and that does equal 2. Now I'm going to plug the points into the second equation, x plus y equals 6. So 4 plus 2 equals 6. Yes, it does. So these do check out in both the graph and the equations, so I know for sure that these are really the coordinates of the point. All right, now we're going to solve this equation that has rational expressions, which look like fractions. And so we are going to do what I like to do first in all these situations, and that is get rid of the fractions. Make them go away, make the denominators cancel. The denominators are 2 and 3. The least common multiple of 2 and 3 is 6. So I'm going to multiply everything here in this equation by 6. I'm going to multiply the first rational expression by 6, the second rational expression by 6, and the constant by 6. If I do that in the first term here, the 2 and the 6 cancel, and I'm left with a factor of 3, which I can then multiply by 5x minus 2. The second term, the 6 and the 3 cancel, and I'm left with a factor of 2, which I can also multiply by x plus 3. And then on the right side of the equation, 2 times 6 is just 12. So if I multiply that 3 by the first term, I'll have 15x minus 6. And then I'm subtracting the next term, which is going to be 2x plus 6. But I'm subtracting it, so I'm going to have to distribute that minus sign to both the 2x and the 6. So minus 2x minus 6, and that equals 12. So now I just need to add my like terms. 15x minus 2x is 13x, and then I have minus 6 minus 6, which is minus 12, and then I still have a 12 on the right side of the equation. Now I'm going to add 12 to both sides, so I'll have 13x equals 24. Divide by 13 on both sides, and you have x equals 24 over 13. All right, so now we are supposed to show that this works in both, in the equation, in the original equation, which is this. So this is the original equation. I'm just going to take 24/13 and put it in for x everywhere I see an x. So 5 times 24/13 minus 2 over 2 minus 24/13 plus 3 over 3, and that equals 2. But, well, we hope it equals 2. We're going to find out if it equals 2. So 5 times 24/13 is 120 over 13, and then minus 2, which is 26 over 13, and that's all over 2. The second part, we're subtracting 24 over 13 plus 39 over 13, because 3 is 39 over 13, and all of that is over 3. Now I'm going to subtract the fractions in the numerator of my first fraction. So 120 minus 26 is 94 over 13, and that's all over 2. And then my second fraction, 24 plus 39, is going to be 63 over 13, and that's all over 3. Now I'm going to change the first fraction, 94/13 divided by 2 is going to be 94/13 times 1/2. So I'm going to rewrite that. And then my second fraction, 63/13 over 3 is the same thing as 63/13 times 1/3. I can reduce these fractions. I'll reduce by a factor of 2 in the first fraction, and that'll give me 47 over 13. And the second fraction, I can reduce it by a factor of 3, so I'll get 21 over 13, and if I add that up, I'm going to get 26 over 13, which is 2, and that's what it was supposed to be. So 24/13 does work in this equation. And by the way, this was number 12 on your test. Okay, so now we have the square root of x squared minus 8x plus 16 plus 2 equals x. Whenever you have a problem that has a radical in it, the first thing you need to do is isolate that radical, get it all on one side by itself, and everything else needs to be on the other side of the equation. So I'm going to subtract 2 on both sides of this equation, and therefore I will have that whole radical is equal to x minus 2. Now I need to square both sides of the equation, and when I do that, I have to be careful, especially on the right side, that I am not writing x squared minus 4 for that, because that's not what it equals. It equals x minus 2 times x minus 2, which you have to FOIL. So on the left side of the equation, when I square that, the radical, the square root, cancels with the square, and I end up with x squared minus 8x plus 16. And on the right side, like I just said, it is x minus 2 times x minus 2. Now, I'm going to multiply that out. X squared minus 8x plus 16 is equal to x squared minus 4x plus 4. The x squareds cancel, so I want to get all my x's on one side and my constants on the other side. So I'm going to add 4x on both sides and subtract 16 on both sides. So I've got negative 8x plus 4x, and then that equals 4 minus 16. Add the like terms, and you have negative 4x is equal to negative 12, so x is 3 if you divide both sides by negative 4. Now we need to make sure that x equals 3 actually does work in the original equation. And we're going to check that. The original equation is the equation before we did anything to it. So I'm going to leave it exactly the way it is and put the 3 in. And that's very necessary. We can't use any of the other equations we had while we were working on it. We have to go back to the very first equation before we even moved the 2. We want to go back to the very beginning. So we're going to put x equals 3 in there for x. Everywhere we see an x, we're going to put a 3. So we're going to have the square root of 3 squared minus 8 times 3 plus 16 plus 2 is equal to 3. We're going to simplify it. So that's 9 minus 24 plus 16. And that is the square root of 25 minus 24. And that is the square root of 1. And the square root of 1 is 1. 1 plus 2 does equal 3. And so we know that this is the correct solution to this problem. And this was number 16. Sorry, I didn't mention that. Okay, so now I want to review how to change polar coordinates to rectangular coordinates, because we're getting ready to learn how to change rectangulars to polars. So we need to do this first to make sure you remember how to do that. All right, first of all, polar coordinates is just another way of locating a point in the XY plane. And remember, the angles that we talk about in the XY plane, we start at 0 on the positive side of the x-axis, then we go counterclockwise to 90, 180, 270, and back around to 360. So we are going to locate this point, the point that is at 7, 230 degrees, and then we're going to figure out the x and the y coordinates we would need to get to that point. So the polar coordinates, like I said, are 7, 230. And so how do we get to 7, 230? Again, we start at 0 degrees. We're pointing in the positive x-axis direction. And then we just start going counterclockwise around in a circle. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230. Okay, so we have rotated around 230 degrees, and now we want to go out from the origin 7 units. So we're coming out from the origin 7. And now to figure out the rectangular coordinates for that point right there, we need to find the vertical distance from that point to the x-axis. That's the y coordinate. And then we need to find the horizontal distance from the origin to where that point would be. And that is the x coordinate. So these are the sides that we need to find. So this side is our x coordinate, and this side is our y coordinate. So we know that the hypotenuse is 7 because that's what we have right here. And so we're going to use our trig functions to find x and y. You might be saying, wait a minute, we don't have an angle. And that's right, we do have to have an angle in order to figure out what those sides are. So what is the angle? Well, it's right here. And we know that we started at 0 and went all the way around to 230. The angle inside this triangle is not 230 degrees. That's the big angle, the obtuse angle that goes all the way around from 0 to 230. But this angle inside the triangle is just the part of that angle that is in the third quadrant from 180 to 230. So that angle right there is a 50-degree angle from 180 to 230. In other words, 230 minus 180 is 50 degrees. So the angle we're working with is 50 degrees. So we are looking for y. That is opposite to our 50-degree angle. So we're going to use sine. Sine 50 is going to equal y over 7. Opposite over hypotenuse. If we multiply both sides by 7, we're going to have 7 sine 50 is equal to y. And now we would punch that into our calculator, 7 times sine 50. So we would hit 7 times 50 sine equals. Okay, so we found our y. Now we want to find our x. So we can use cosine to find x because our angle right here, the adjacent side is x. So cosine 50 is going to equal x over 7. Multiply both sides by 7, and you get cosine 50 times 7 is equal to x. If we punch that into the calculator, okay, so if you remember, I was telling you when we learned this the first time that you need to be careful with your x and y because you have to notice what quadrant you're in. So we are in the third quadrant. This is the part of the xy plane where x is negative, you go left, and y is negative, you go down. So all the points over here in this quadrant have a negative x and a negative y. So we have to make sure we put those negative signs here in our answer so that we will be in the correct quadrant. So our y is 5.36, that goes here, and our x is 4.50, which would go here. So those are the rectangular coordinates of that point at 7, 230 degrees. That's how you change polar coordinates to rectangular coordinates. So let's try another one. This one, we're going to change 42, 340 degrees to rectangular coordinates. So go ahead and stop the video and try this one yourself and see if you can figure that out. Okay, so 340 degrees, we're going to do it just the same way we did the last time. Starting at 0, we're going to go counterclockwise all the way around. We went to 230 last time. We're going to keep going all the way to 340. So 240, 250, 260, 270, 280, 290, 300, 310, 320, 330, 340. So that's 340 degrees. We want to find the x, the horizontal coordinate, and the y, vertical coordinate, that go to that point. We came out from the origin, 42. So 42. And remember, these drawings don't have to be to scale. You just need to label them with the values. All right. So the angle this time is right here. That's the angle between the x-axis and the radius of our polar coordinates. And we use that angle always, the angle between the radius and the x-axis. This is the right angle. And that angle there, this time, is you've gone all the way around 340. All the way around total would be 360. So this little angle here is 20 degrees. It is 360 minus 340. So that angle is 20 degrees. And we're going to use that to find our x coordinate and our y coordinate. So sine 20 is equal to opposite, which is y, over hypotenuse, which is 42. Multiply those sides by 42. Punch it into your calculator. That is about 14.36. Now we'll find x. Cosine 20 is going to be x over 42, adjacent over hypotenuse. And multiply both sides by 42. 42 cosine 20 equals x. Punch that into the calculator. That is about 39.47. And remember, now we're in the fourth quadrant. And in the fourth quadrant, x is positive and y is negative. All the points in this quadrant, you go to the right and down to get to them. So that means positive x, negative y. So positive x, negative y. So our y is 14.36 and our x is 39.47. we want to add these two vectors and get the resultant vector. So we've got the vector 420, which means go 20 degrees counterclockwise and go out 4 units. And then we want to add the vector 7, negative 230. So negative 230 means go clockwise 230 degrees and then go out from the origin 7 units. Okay, so to change these polar coordinates to rectangular coordinates, we're going to need to make triangles. So we're going to make triangles between the x-axis and the point. All right. And so we're going to deal with the angles between the x-axis and the radius. In the first quadrant, the angle is 20 degrees. We already knew that. In the second quadrant, in the second quadrant, this angle inside the triangle is going to be, you got 230 all the way. So when you're following this little trail, you're going 90, 180, and then how much further do you have to go to get to 230? That's going to be 50 degrees. All right, so those are the two triangles we're going to be dealing with, and we're going to find the x and the y for each triangle. The x is the horizontal leg, the y is the vertical leg. And so this point right here, remember we're in the second quadrant, so the x is going to be negative and the y is going to be positive. And for this point, that is going to have a positive and a positive because we're in the first quadrant. So now we're going to use sine and cosine to find those values. So in the first triangle with the 20 degree angle, you know that sine 20 degrees is equal to opposite, which is y, over hypotenuse, which is 4, which means that y is equal to 4 sine 20. And then cosine of 20 degrees there is going to be adjacent over hypotenuse, so x over 4. And if you multiply both sides by 4, you get x equals 4 cosine 20 degrees. All right, so we can now punch those values into our calculator. The y-coordinate is going to be 1.37, is going to be about 3.76. And so that is going to be that point. So I'm just going to write it over here, 3.76 and 1.37. And now we'll look at the other triangle over here in the second quadrant. So here we're going to have sine 50 degrees is equal to opposite y over hypotenuse 7, which means that y is equal to 7 sine 50. But remember, pay attention to what quadrant you're in. When I say y, I mean really the absolute value of y. We don't get the actual sign that we necessarily want. So we're in the second quadrant, y is positive. So when we punch that in, we'll get a positive value. And then cosine 50 is equal to x over 7. And that means that x is equal to 7 cosine 50. But in this case, we're going to have to put a negative sign in front of it because in the second quadrant, x is negative. So we're going to punch it in. That's going to be our y, 5.36. And then our x is 7 cosine 50. So cosine 50 times 7 is going to be about 4.5. So that's going to be negative 4.5. All right, so I'm just going to write both points over here because I want to add them together. So negative 4.5 for my x on that one and 5.36. We're going to add the two forces together. And in your book, just to make sure you know, this would be written as 3.76i plus 1.37j, and the other point would be negative 4.5i plus 5.36j, and then you would add them together, And so minus 4.5, going to get about negative 0.74. And then 1.37 plus 5.36 is about 6.73. So 6.73J. And if I just use the coordinate pairs, I'll get the same thing. Obviously, negative 0.74 for X and 6.73 for Y. All right, and the question is find the resultant, which means the resultant vector. So you are going to have to change this back into polar coordinates. So